Day 38, Honors Physics, Newton's three laws. Problem number 6. Here's the initial diagram and then the free body diagram for each of the two boxes or blocks. It turns out that it's easier to start with the larger block in this case. Once again, the action-interaction, Newton's third law pair of forces between the two boxes is 12 newtons. Small box pushes on big box pushes back with the same force but in the opposite direction on the little box. But if you apply F net equals ma, there's no friction here. The F net equals ma for the 6 kilogram block. Well, the 12 newtons is the F net, so you have 12 equals 6a, so a must be 2 meters per second squared. So that's the acceleration of the big block, but it's also the exact same acceleration of the small block because they're both moving, accelerating together. So that's why it's easier to start with that block and then apply F net equals ma to the small block. I'll do that in black. F net equals ma. But the little block has two forces, once again no friction. The bigger force is F that I've indicated in blue. So it will be F minus 12 equals 3 times 2, which we now know from what I just calculated. So 3 times 2 is 6, plus 12 is 8. F is 18 newtons. So I think in the next problem, which I'm not going to do, problem number 7, they give you the same scenario, but they have you pushing on the big block, say from the right side, pushing towards the left. It comes up with a different answer, but the 12 Newton interaction force is still the same force between the two blocks. In other words, the big block is going to be pushing on the small block with 12 newtons. The little block is being pushing back on the big block with 12 newtons. The system, you know, in my directional frame here would be accelerating to the left. But in that case, what you want to do is start with your F net equals ma on the small block, because the small block then would only have the single 12 Newton force on it. It would not have the force pushing on it from the left-hand side like we have here. So basically, you're going to kind of work the problem opposite of this one. You will get a different answer, even though the force between the two boxes is still 12 newtons of interaction.